Okay, so now welcome back. What we want to do in this video, we want to count up to 20, and these are essentially one way that you can express, that you can essentially represent these numbers 10 to 20. So then again, a complete box over here, that basically represents the number 10, meaning 5 and 5, that would be 10. So then again, a complete box would be 10. So if I were to basically to count these suites over here, I would say basically 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And that would be number 10. Again, for number 11, I could again say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, right? So for 12 again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see that essentially I'm counting over and over again. But the thing over here is that essentially as soon as I count this one time, I count this once, and I know that there is 10 suites in this box, right? And then for the next time, as soon as I see one complete box, then I know that there is already 10 suites in there, so I don't have to count it over and over again. That's essentially one of the ways that you can actually use this model. So then I know that essentially I have 10 suites in here, so that's basically the number 10. Now over here I see that I don't have to count anymore. So I have a 10 over here and a 1. A 10 and a 1 would be an 11. Again, I have a 10 over here and a 2. That would be a 10 and a 2, which is a 12 basically. Again, a 10 and a 3 would be 13. A 10 and a 4 would be 14. A 10 and a 5 would be 15. A 10 and a 6. Of course, this one again, for example, you have to count, meaning that I already know that this is a 10, but then this is half of the box, so that's a 5. So that's a 10 plus a 5 plus a 1. A 5 and a 1 would be a 6, so 10 plus a 10 and a 6 would be a 16. Again, over here, I have a 10 over here. I have a 5 over here and a 2. A 5 and a 2 would be a 7. And then a 10 and a 7 would be a 17, right? Then again over here, I have basically a 10, a 5, and a 3. So a 5 and a 3 would be an 8, a 10 and an 8 would be an 18. Over here I have a 10, and then I have a 5 and a 4. A 5 and a 4 would be a 9, so a 10 and a 9 would be 19. And again over here I have a 10 and another 10, a 10 and a 10 would be basically a 20, right? Okay, so now another way of doing the same thing, you saw over here that basically the model that we used for these numbers basically were these boxes. So for example, I had a complete box over here which contains 10 suites. And then I have essentially 3 loose ones, right? So I have 1, 2, and 3 loose ones over here, and a complete box. And that would be essentially a 10 plus a 3, that would be a 13. So another model that we can use in order to represent these numbers is basically this model over here, which is essentially just a bunch of sticks. And each stick is going to represent essentially a 1. So now I'm assuming that essentially this is 10 sticks over here tied together, right? So that's essentially one complete group. That's exactly the same thing as this. That's exactly the same thing that we had over here. A complete group of 10 in one box. And then over here a complete group of sticks in one bundle basically, right? So then I'm going to think of this as a 10, and then I have these loose sticks over here which is essentially 1, 2, 3, 4, 5, 6, and 7. So that's basically a 17, for example, right? Or basically the exact same, essentially the exact same model, I can represent it like this. For example, instead of sticks, I can use basically these leaves over here. And so that would be essentially 1, 2, 3, 4, 5, 6, 7. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you see essentially one complete set over here, essentially one complete bundle over here, or one complete bundle over here. So that's a 10, right? And then 3 loose ones over here. So that's a 10, a 10 and a 3 would be a 13, for example. Again, but then we can kind of formalize this scheme over here, meaning that we can simply use these frames. And then when you use the frames, then you have essentially, for example, for 14, you will have basically a complete bundle, basically. For example, a bundle like this, or a bundle like this, or essentially one of those complete boxes that we had before. So this is a complete box, and you see that essentially all of the grids have been basically shaded here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And then I have 4 loose ones over here, so that's a 10 plus a 4, that's a 14. And then, for example, for a 19, you would shade essentially all of these boxes plus 9 of these. So that would be a complete box plus 9 loose ones, which would essentially look something like this. So I have basically a box like this. So I have 1, 2, 3, 4, and 5, right? I have these, basically this complete box over here, and then another one for the loose ones. 1, 2, 3, 4, and 5, right? And now basically I want to essentially to create the number 19, for example. So how do I do that? I will shade essentially this box over here, plus this box, 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 and this box, and this box, and this box. So that's a complete box, which essentially represents a 10, basically, right? This one basically represents a 10. And then I want to represent a 19. So and a 19 would be essentially a 10 plus a 9, basically, right? So a 9, so a 19 is nothing but basically a 10 plus a 9, and a 9 is nothing but a 5 plus a 4. So I shade essentially 5 of these over here, and then another 4 over here. That would be essentially the number 90, right? Okay, so now let's do number 16, for example. For number 16, I'm going to need essentially a 16 is essentially nothing but a 10 plus a 6, right? So a 10 would be a complete basically a complete box, basically. So for a complete box, I'm going to shade everything that I have over here. So this would be essentially a 10, right? And a 6 would be a 5, meaning essentially this grid and this grid and this grid and this grid and this grid. So all of this is a 5. And then a 1 would be a 6. So this is basically a 6. So then 10 plus a 6 would be a 16. So this is essentially how you would represent essentially the number 16. Now again, we have basically, for example, these models for these numbers, and we want to, and we are supposed to essentially connect them together, right? Match them together. Now you see, this is essentially, now I'm going to go through this painful counting to show you essentially what it means in order to group things together properly. For example, you see over here, if I were to know what number this represents, I have 2, 4, 6, 8, 10 and 12 leaves over here, 13, 14, 15, 16, 17, 18, 19 and 20. So that's a 20, and then I would connect it to this 20 over here, right? But then you see that I have to count each and every one of the leaves in order to essentially to know what number that represents. Or for example, these buttons, I don't really know what the number is. I have to count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's a 16. So you have to count it, okay? Again over here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. So that's a 17 over here. But again, you have to go through counting. And now suppose that, for example, I had, for example, I don't know, 120 of these beads over here. So that would be, it would take me a long time to count essentially all the beads. And then there is, for example, over here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and that would be this 10 over here. So this is essentially these objects over here that have not been that haven't been grouped properly, and so you have to count them, right? What you could do instead is that for the exact same thing, meaning that we have these numbers basically as 17, as 16, a 20 and a 10. And for example, we had these buttons over here. Now let's say that for example this button, these buttons is, for example, that's a 3, 4, 5, 6, 7, 8. I'm going to represent everything essentially with buttons. Now let's say that I had 17 buttons. I could basically put these buttons essentially like this, put together, and without grouping them, and then again I would have to just keep counting, meaning that I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on and so forth, right? So this is not easy. An easier thing to do would be to say that, okay, so I have 17 buttons, so I put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a 5. So that's a complete box basically. That's a 10. And then 1, 2, 3, 4, 5, 6 and 7. So that's 7 loose ones and a complete box. So this way I don't have to count anymore. So that's a 10 plus a 7 would be 17. Again for 16 I would again group them together. I would say that essentially that's a complete box. And then, for example, 6 loose ones over here, and that would be a 16. For a 20, I would simply draw, basically group things together, and then draw essentially 2 of these boxes. For a 10, I would draw only 1 of these boxes, and then essentially you wouldn't have to essentially keep counting everything over and over again, right? Okay, so that's essentially all about basically representing these different numbers basically, right? In the different models that you can use in order to represent these numbers. I'll see you in the next video, and thank you.